Hello, we see you again. So we start our lesson today. There's a lesson 6.5 from 4 Optical Instruments. So this one's the second last for your topic light. So hope you understand about this topic. So I will continue the next one. Okay, let's see the first one that introduce about the optical instrument. From here, I want to introduce, actually, you've got 3. There's a main of the optical you need to learn for the Form 4 lesson. Okay, first one, there's a magnifying glass. From this one, magnifying glass, before that, we learned already. We also know how to draw the diagram. So we see what's the function for magnifying glass. They want to magnify the image. Okay, this one is an example. They're using the magnifying glass for the first diagram. Second diagram, you're going to check your eyes, and also this one and another one, they're using the magnifying glass to observe the smaller object. Okay, the lens we're using normally is a convex because you want to make it become larger, so magnify, so we're using convex. So the location of the object distance must u less than f. So when you see this word, there's more familiar. Before that, we draw also the ray diagram. Okay, let's see the next one. Okay, now this one is a diagram for the magnifying glass. Remember, is it u less than f when we draw about the lens diagram? Okay, object distance, they're less than the focal length. So that means now your object is near with the lens. That means far away from the f, still between. So we said the object distance less than the f. Okay, now characteristic. So you find it, the image they form at the part 1. This part should be the virtual part because they're above the horizontal line. So virtual part, we draw it as a dotted line. So you find it there's a virtual, then the partner should be upright. Then last one, we're going to find the size. The size become bigger. So the final image should become bigger because there's a magnifying glass. So that means you're using magnifying glass to make the object finally become larger so you can see. So that means the image must be magnified. Okay, magnifying glass, they want to magnify the power increasing if the focal length of the lens is shorter. So if the f becomes smaller, you find it the lens, the power will become higher. So that means the power and focal length should be inversely proportional. So that means you can say power higher means there's a thicker. It's more thicker, that means the focal length becomes shorter. Okay, now we're going to see how to produce a line. We're still using the first ray and also the third ray to continue to draw. Okay, let's see the first ray, parallel, then go to find f. Okay, then we continue. Okay, third ray pass to the center of the lens. So you find it, these two lines is actually, they also cannot join because they go further and further. So what we need to do, we need to extend. Okay, you extend, you need to draw at the part 1. So part 1 should be the virtual part. You need to draw about the dotted line. So we make the red color, the first ray, longer. Extend become longer. Okay, using the dotted line. Okay, now the blue color line, that means the third ray, I also extend. So they find it, they're using dotted line. Then they cross already. When it just cross, we know the final image must be located here. Okay, now we need to draw the final image. Must draw from the horizontal line. So you start from here, then you draw up. Okay, don't draw here. Here is wrong. You must start from the horizontal. After that, you start extend the arrow go up. So now I show the image. So this one is a virtual image. So we now to compare. This part is a virtual. Okay, then you find it both is the same, the head at the top, this one head also top. So this one we call it there's an upright. Okay, they never inverted, they're still upright. Okay, final, we compare the size. This one should be magnified. Okay, so this one is a magnifying glass, the ray diagram, how to draw. Okay, you must remember is where's the location for the object, then what's the function for magnifying glass, and also the characteristic for the final image. Okay, now we need to go is another one. There's a more harder a little bit. We're using both convex lens combined become microscope. So everybody know microscope, the function is They want to view the small object just like the microorganism. So from here, we're going to introduce how to build, or you say how to set up the microscope. Okay, we're using two powerful convex lenses of the short focal length. Powerful means high power, focal length must be short. Okay, so these two powerful convex lens, one we call objective lens. So the focal length we label by FO. Okay, another one is an eyepiece lens, FE. Objective lens must face to the object. Eyepiece lens must go to your eyes. So that means the location must be the object in front. Okay, eyepiece must put behind, because you want to focus the object first. Later you can see the image. Okay, now I want to explain about powerful. Powerful means the focal length become shorter, is it? But they still got a little bit different. Okay, a little bit different, maybe small only. Okay, now we're going to see the FE and FO. Sure, either one is become bigger, but they're bigger a little bit only. So we're going to see the diagram. Okay, this one is an example for the microscope. Okay, now we need to explain more detail. Okay, now we're going to see introduce the focal length of the objective lens. There's a less than FE. FO less than FE, just a little bit. Maybe this one 5 cm, this one just of 6 cm. That means just a little bit different, but both also is a high power. Okay, distance between the objective lens and the eyepiece lens more than FO plus FE. Okay, now we refer this diagram. Okay, this one we call FO. This one we call FE. Okay, FO means distance between the center go to the F. So this one we call focal length for the objective. Okay, FE is located here. This one is the center for eyepiece. So now this one we call focal length for the eyepiece. So now they say FO is shorter than FE. Yeah, that's correct. FE is longer here, is it? FO is shorter. Okay, now you need to see the distance between the objective and also eyepiece. Okay, object is here, eyepiece is here. Both distance, is it more than FO plus FE? This one is FO. This one is FE. Can you see the center? They still got the space. This one space, we don't know how many cm. But I just know these two lenses distance sure bigger than FO plus FE. Example, this one is 5 cm. This one is 7 cm. So actually, both plus together just 12 cm, is it? Okay, this one 5, this one 7. But can you see the center? They got extra. So I cannot say both distance become 12 cm. Okay, I just can say they're more than 12 cm. Okay, so this one we call setup. Okay, they want to set up like this because later I want to magnify the image. Okay, now we're going to see number 3. Object distance. Okay, this one object must located between FO and 2FO. That means they must between. This one is FO. This one also FO. But behind we got 1, 2FO. So your objects must located between. Objective lens can form the first image. So this one is the objective lens. When the object just pass, first ray, pass to the F. Second ray they never draw. They straightforward draw the third ray. Pass the center, go down, so they cross already. So can you see this one is the first image. This one first image from where? From the objective lens. So now we can say the characteristic. Okay, can you see there's an inverted? And also there's a real image. This one already is below. Below sure is a real. Then inverted. Then after that you find it become magnified. They're bigger a little bit from the microorganism. So there's a real, inverted, and also magnified. Okay, now we go through another point. Okay, now we want to explain about the first image. Okay, first image, where's the location? They must located between the center of the eyepiece and also the focal length of the eyepiece. That means they just can between this location only. You cannot more than FE. You cannot in the center of the lens. They just can between this location. So this one we call first image. Okay, let's see the explanation. I1 lie between the FE and optical center of the eyepiece and become the object for the eyepiece. Okay, when you just form the first image, so we no need to see the objective lens already. Now we need to focus eyepiece. So this one image, first image, will become the object for the eyepiece lens. Okay, so just now this one is an object. After you form the first image, so the first image will become object already. So they say they become the object for the eyepiece. So eyepiece lens function, what's this one function? The eyepiece one will put behind for what? That as a magnifying glass. That means this one just magnify a little bit. But when you put the eyepiece lens, they will make the final image is more bigger some more. So this one we call it magnifying glass function for the eyepiece lens. Okay, now we continue. The eyepiece lens form the final image. There's an I2. So when you see, when it just pass through this part, so this one become object already. So this one object, the bottom, pass the center. Straight, go down. Then another one, you draw the straight line, you come here, then you draw, pass through FE, then go down. Then the rest, you just continue to join the line. This one line is a broken line. You continue to draw the line, go downwards. Okay, so finally they say this one is a final image. There's an I2. How about the characteristic? There's a virtual, because this one, why we call it there's a virtual? Because this part we compare with the first object. Normally the virtual is a part 1, is it? But this one special. This one special is the final image that at the another part, but they're still virtual. Although they are below, but they're still virtual. Then that is a magnify, sure magnify. Okay, but virtual normally the partner should be upright, is it? But this one is an inverted. Why there's an inverted? Because we compare with the object. Okay, can you see the object is up? But this one when I draw there's a terbalik. So that means when I compare the final and the original object, that should be inverted. If I compare the I2 and I1, should be upright, is it? So from here we don't compare with the image, want to compare with the object. So the final image, remember, there's a virtual, inverted, and also magnify. Okay, so that's why virtual, because you're using the microscope. When you just see the image, actually there's a virtual image. When you're using the screen to close it, that means you cannot see. Okay, another inverted, you will ask, if the image become inverted, then how to find it? So normally the microscope, you want to see the microorganism. If the microorganism inverted, also never mind, because we also do not actual what's the shape of the microorganism. If you say you want to see the people, then inverted, that means cannot lah. You must see the upright, is it? The one is binocular. So microscope, remember, they want to just observe the small object, just like the microorganism. So that means that it's inverted. Okay, so this one is a characteristic. So what you need to know, the first part, you need to know where's the location for the object you want to put. Okay, after that, you need to know FO and FE, which one become longer. And the distance between the two lenses must more than FO plus FE. Then you need to know the first image, what is the characteristic. There's a real, inverted, and also magnified. Okay, next one, you need to know where's the location. I1. The location must be between the center of the eyepiece and also FE. Okay, next, so this one become object already. So eyepiece was a function that as a magnifying glass. So after that, they produce a second image. This one second image, what is the characteristic? The characteristic is a virtual, inverted. After that, there's a magnify. Then how we compare? We compare with the object. So this one is all the characteristic you need to know before we want to build this microscope. Normally the question they will call you to draw, but they want to explain how to build the microscope. Okay, so this one, when I just magnify the image, they become like this. Okay, you must see clear the line how to draw. Okay, they're just using the first ray and the third ray. Okay, when you just get the first image, then draw one dotted line, go another one, there's an eyepiece. Now you continue to join the eyepiece line. Okay, I will step by step to show you how to draw. Okay, now I want to show the ray diagram of the microscope. You see how to draw. Okay, first one we show you there's a FO, another one is a FE. So the FO distance, we count one box is 1 cm, this one just 2.5. If the FE, they got 4 boxes, so there should be 4 cm. So the FE must be longer than FO. Okay, now we got show 2 lenses. The distance for the 2 lenses must more than the FO plus FE, because the center we still got the space. Okay, now I start to draw the first ray. Parallel, then touch to the focal point, there's a FO, then hit to the eyepiece lens. Okay, now I continue to the third ray. Okay, the third ray straightforward, we pass through the center of the lens. Okay, I continue to draw for the second ray. Okay, depend for yours. If you don't want to draw the second ray, it's okay. Just like the just now diagram. Okay, now I find it the 3 line together cross. So sure there's a image here. So I draw my image. So my image still located between FE and also the center of the lens. That means you cannot out. You must locate it here. Okay, now what is the characteristic for this one image? So this one image is a real. There's a inverted and also magnified. But this one magnified just a little bit. Okay, now I continue to form the second image. Okay, second image, I draw the dotted line from the center of the eyepiece, go to the first image. Okay, this one image become object already, just one straight line. Okay, second one, I continue to draw this one, the green color light, that means the second ray from here. Okay, I join to the FE. This one is another FE, then I join it. Okay, then the rest I just continue to cross, because they already crossed at the point here. So finally, I find it the 4 ray. They also cross at the same point. So I know this one is the location for my second image. So I draw second image. Okay. So this one second image, what is the characteristic? The image should be virtual. Okay. Then after that, there's an inverted, because compared with the object. Final, there's a magnify. Okay. So this one is an image 2. So this one you need to repeat and repeat to draw. Okay, you must know the every ray how to function and also the characteristic. Okay, now I redraw again. So first ray. Okay, before first ray, I want to show FO and FE. What's the name first? Okay, first ray. Then continue, go to FO. Okay, this one slow motion. So this one is a FO distance. Okay, this one is a FE distance. Okay, now I join third ray from the object center, go straight. Okay, then I need to draw the second ray also. Okay, finally I cross. So this one is my first image. Okay, then I continue to draw from the first image. I go to center. Then I continue this line, go to FE. Okay, then the rest continue because they cross already. We just continue from your eyes there. Then we continue. So finally, you can see the image is located here. Then you draw your second image. Okay, now we show characteristic. First image, real, inverted, and also magnified. Okay, then the second image, virtual, inverted, and also magnified. So this one is a characteristic for 2 image. Okay, then we finish about the ray diagram. Then we got magnification for calculation. So the magnification is a MO multiply ME. MO is stand for linear magnification for the objective lens. Then the ME is for the eyepiece. So we separate one by one. MO actually is a HI over HO. Remember before that we learned how to find the magnification. There's an image height over object height. So the first one object, the image height is the first image over the object height. Okay, ME is an eyepiece. Now eyepiece, they take the first image become object. So that's why they take H2. H2 is the second image over the first image. Okay, now I take this whole the info, I put inside the formula. So you can see the total magnification M is stand for HI over HO. That means there's a MO. Okay, multiply ME. There's a H2 over H1. Finally, which one we can cut? So the H1 and H1 actually is nothing. We no need to use. When we just cut already the final magnification for the microscope, there's a final image, there's a H2 over the object. That one is a magnification for the microscope. Okay, so we just finished the microscope. So there's a little bit more for explanation. So hopefully you are practice to see how to draw, how to build the microscope. Okay, then we go to telescope. Telescope a little bit better than the microscope for the explanation. Okay, we see how better. But normally the question they ask is a telescope lah, because they're easy to apply. Okay, first one we need to know application. They view the distant object like the planets and also the star. Okay, they want to see the objects very far one. Okay, so if they're very far means they're sure it's a parallel line, is it? Okay, now we continue. Objective lens. So they're still using two lenses, objective and eyepiece. Okay, now it's reverse. Objective lens is longer focal length. Just now objective lens is shorter. Now this one is longer. Okay, eyepiece length is shorter. Okay, FO and FE. Now the FO is longer than FE. How longer? There's a more and more. Example, FO may be 100. Then the FE may be 10. So this one is a big difference, is it? So this one is a telescope. There's a more bigger. Why they want more bigger? Because they want to produce final, the image is infinity. So they want to produce a big difference. So that's why they cannot focus. Finally, you can see the image. They're exactly infinity parallel ray. Okay, now we go and find it. FO more than FE. So remember this symbol. Okay, then more so much. Just now, just a little bit. FE more a little bit than FO. But telescope, there's a FO more bigger and bigger than the FE. So there's a big difference. Okay, now we continue to see it. Distance between two objective lens and eyepiece. Okay, I want to introduce. This one FO. This one is a distance from the center to FO. This one we call objective lens. From the FE, go to center, we call eyepiece lens. Can you compare? FO actually is longer than FE. Okay, and longer more. Okay, after that, one more point is here. FO and FE located at the same point. Okay, this one is FO, is it? This one FE, is it? FO and FE located at the same point. So I can say now the both distance, objective lens, eyepiece lens, the distance is exactly FO plus FE. If I say FO 50 cm, FE 10 cm, so total distance 60 cm. Okay, but microscope just now is more than 60 because the center still got the space. Okay, so this one is a what different telescope and microscope. Okay, now the parallel ray from the distance. This one we call parallel ray. Parallel means they're from the very far. Okay, the object is very far. After that can be focused at the focal plane of the objective lens. Okay, so from here, that means when they just come the parallel, they will find what? They will find the focal point. Okay, then after that they form the first image. So can you see? Three, they come together. Center, this one is a third ray, straightforward go. Okay, this one is a second ray. When they just go, then parallel. Okay, this one is a first ray because we cannot see the first ray because they're far distant. We don't have any object. So they just draw parallel. After that, touch to the line, then they bend. After that, they focus to one point. Then this one point, sure, they must locate it at the FO and also FE. Guarantee already. That means you cannot move then you must set your image is exactly below the FO and FE. Okay, then after that, we draw the second part, become I1 become object. Okay, then we draw again for the eyepiece lens. Okay, now we continue to explain. Okay, repeat again. This one FO, this one FE. Your I1 must located at the point FO and FE. Okay, then this one become the first image. Okay, then the first image, what is the characteristic? So this one first image sure is inverted, because you find it there's an inverted, and also there's a real image. Okay, another one, this one not magnified, this one is a diminished, because they compare with the verified object. Verified object sure very big, but this one become diminished, become smaller. Okay, now we continue to explain. First image, real, inverted, diminished at the focal point. So the keyword is focal point. Okay, number 2, the first image that will become the object for the eyepiece. Okay, eyepiece lens from the final image. Okay, this one is an eyepiece. So the first ray, how to draw from the image, go to center. Then the rest, you just continue to draw the line. All the line just parallel. Okay, so the eyepiece lens, they form the final image. There's an I2. So from here, you cannot see the second image because already is a parallel, means there's an infinity. So from here, we call it there's a virtual, then magnified, and also inverted. Remember why virtual and inverted now become partner? Because we compare to the original object. Okay, we just got this citation, microscope and telescope, virtual, inverted. The rest, virtual sure is a upright. Okay, so you add one more characteristic, there's an infinity. Okay, normally image 2 is located at the infinity, so this one we call it as a normal adjustment. How to produce the final image is an infinity, so you need to adjust. 2 distance for the lenses must be FO plus FE, then you can produce infinity image. So this one is a telescope. Okay, now I zoom, make it become bigger, so you can see this one is a FO, this one FE, then this one first image. Then the second one, that from the eyepiece, you make sure you know how to draw. From the image, that means the first image go to center. Then after that, the ray, you just continue parallel to draw. Finally, they form the image. Okay, now we practice how to draw. Okay, this one is a parallel ray from the distant object. So we draw the third ray first, because third ray straight line. Okay, this one is the first ray. Then third ray. Okay, because you set already, this one must be your image. Okay, before you start to draw, you set your image first, because image must be located at this point. Okay, now, so 3 ray join already, so this point should be the first image. Okay, then I continue to draw from the eyepiece. Okay, from the center, go to the image, first image. Then we continue, make it become longer. Then these 3 lines just continue become parallel. Okay, parallel. 2 lines become parallel, then we continue. Then the rest also same. So this one I say they're more easier to draw because they no need to cross. They're just parallel only. So this one we call it the second image, we cannot see. The second image already is a infinity. Okay, I redraw again for the slow motion. Okay, so this one is the third ray. Second ray. Okay, your image already is located here. You set first. So the first ray, you just cross at the same point. So this one already is a first image. Okay, now we draw from the eyepiece. Okay, continue to draw, touching FE. Then the rest just parallel. So you find it, this one should be the second image. Okay, second image, there's a located at the infinity. So we see the characteristic. First, there's a real, inverted, diminished. So the second one should be virtual inverted magnify. Okay, normal adjustment of the telescope. Remember, there's a L equal FO plus FE. Okay, now we go and see how to find the magnification. Okay, the final image can be formed at the infinity. So the magnification for the telescope, M equal FO over FE unit. Okay, we don't need so many calculations just like the microscope. There's just a simple FO over FE. Because the FO sure longer than FE, is it? Your final image sure is more than 1. Then the final image must be magnified. Okay, now we go and see the application. Now we're using the small lenses in the optical instrument for technology. We're only using the big one. Okay, example, the lenses are widely to use for smartphone, camera, and also the closed circuit television. There's a CCTV. They're using the small lenses already. Before that telescope, microscope, they're using the big one. So that's why the object become very larger. Now they're using the small one because they want to create the object become smaller, just like your smartphone and also the CCTV. So let's see the example here. This one is a lenses in a smartphone camera. Okay, so that's why you can find it. They're very small size only. Okay, another one should be your CCTV. They're also using the lenses. Okay, another one should be your car camera. They're also using the optical instrument. There's lenses, but the size should be smaller because you want to make it now the object or the application thing must be smaller size, is it? So they want to create the lenses also must be more smaller size. Okay, now we explain the smartphone and the CCTV. They have the camera. There's a high resolution to capture the picture and also to record the video clear. So the smartphone and also the small size CCTV have small size convex lens. They're using also convex lens, but the size is smaller. Okay, thin lens can be formed, an image that's a real, diminished, and inverted. They can form the real image, and also there's a diminished if compared to the original must be smaller, and also there's an inverted at the sensor. So you want to become upright, so you must reverse back. Okay, the last one is a minimum distance between the sensor and the center of the lens has to be same as the focal length. If it just located same as the focal length of the camera, that means you can get the actual image become more clear. So this one is a minimum distance, so you cannot too closer. They must exactly more than the focal length. Okay, so this one is a formation image from the small lens using by the smartphone, camera, and CCTV. So this one is a few of the version. Okay, vision is here. This one is the object distance. This one is the focal length. So this is the size of the sensor. So the lens must be located at the focal length. Okay, then from here, just go here. The size sensor exactly at the focal length. Finally, they can cross at the center, then capture. Okay, few of the version. Okay, now this is a formative practice, 6.5. Now you need to answer this question. They just call you to find the magnification for the telescope. They provided eyepiece focal length. Then the 4 pieces of the objective lens, there's a A until D. Okay, so you need to complete the table. Okay, first one, how to find the telescope magnification. The formula should be FO over FE. So you just do the calculation. FO is 14 over FE means there's a 2 lah. Okay, this one also same. So another one should be 70. Okay, I told you already, telescope must be big different, FO and FE. So FO is 70, FE is a 7. There should be 10. So you find it, this one is a big magnification. There's a better for telescope. Okay, this one is the diameter for the objective lens. What's the function for diameter? Diameter bigger, better, or smaller? Should be bigger is a good. Why there's a good? Because bigger diameter means more more light can enter the lens. If more light can enter the lens means your image become brighter. Okay, that's a good for your observation. Okay, so from here we log already. Magnification must be high, diameter must be large because more light can enter it. Okay, then we continue the next question. Okay, you need to state the 2 lens lenses which can be produce the largest image. So largest image, we just see the magnification, then should be C and also the D. So lens C and also the lens D. Okay, state the two lenses can produce the brightest image. So the brightest image must be the diameter should be larger. Then there's a B and also the D. Okay, the last question, based on your answer 2 and 3, state the most suitable. So just now we got B and D, C and D, is it? That means the most suitable should be the D lah. So we answer there's a lens D. So reason you just explain the characteristic only, because they have the bigger magnification and also there's a large diameter of the objective lens. So we just repeat, because it produces a large magnification and also has the bigger diameter of the objective lens. So this one is the answer for the question 4. So this one is the last one. So hopefully you understand. So please practice to draw. I got pass you the exercise, they got drawing diagram. So you can follow the step by step to draw the image formed by the microscope and also telescope. For the last topic, there should be the 6.6. Okay, so see you soon. Thank you for your watching.